All right, here we are with hyperbolas, and so we have already worked with, so we know that it would be like x squared over something minus y squared over something equals 1. But what do we do if the center moves? Well, it's the same as all the other things when the center moves, so let's see. We're going to say that the center is at HK. So what does that look like here? If the transverse axis is horizontal, so if it goes like this, well then the x squared comes first, right? And it's always minus whatever the h is. If you don't like the h, just put a blank there, totally fine. Now, this one is over a squared minus y minus h all squared over b squared. Okay, so in hyperbolas, what changes? Do the x and the y switch if it opens separately, or does the a and the b switch? And I will tell you, look, okay, here's what we do. So in ellipses, your a and your b switch, depending on if it's wide or tall. But hyperbolas, if it opens side to side, the x will come first. If it opens up and down, the y will come first. So here are your formulas. The h always goes with the x, k always goes with the y. Notice they're always minus, and then this in the middle is minus. And so then how do we find our foci? Is that even in here? I don't think it is. So c squared equals, we know we've got our a squared, b squared. Well, because it's going like this, it's farther away. The foci are farther away from the center than your vertices, so you add it. So again, it's always the opposite sign. So for ellipses, you subtract. Hyperbolas, you add. Let's try one. All right, first I look for the center. So what goes in the x and the y spot to make this, like the center, the 0? It would be positive 1, positive 4. Because 1 minus 1 would be 0. 4 minus 4 would be 0. Okay, so over 1 of 4. There it is. Now, identify the center. Got it. Vertices. Well, since the x comes first, it's going to look like this. So my vertices come from here. So A equals 2, because 2 times 2 is 4. Okay, so it's going this way, so that's adding onto the x points. So I add 2 minus 2. If you're like, I need to graph that. Okay. There it is. There it is. So my vertices are at 3, 4 and negative 1, 4. Now, I don't call them co-vertices. I just want to see where else my rectangle goes. So I'm going to go, my B is 3 because 3 times 3 gives me 9. So I go up 3, down 3. I don't have to like write that down so much as that's how I make my box. So here I'm going to grab on, make a little, it's a dotty box because it's not actually there. It's just helping us make our asymptotes. So now I grab onto my asymptote tool and, ooh, look, it's down 3, right 2. So I can start here. Now that's going to give me kind of a gross y-intercept, so I'm probably not really going to like give you an equation for my asymptotes this time, and that's fine. Now that one went down 3, right 2, so this one is up 3, right 2. So there we go. And then I decide the x was first, so it goes like this. So if it helps you to make it with your body first, like when you ask me questions, I'll say, hey, make that with your body, because that will help you. And then I draw it within. There it is. All right, now I need to find my foci. So foci, c squared equals a squared plus b squared. So that's 9 plus 4, so 13. See where I got the 9 plus 4? I kind of skipped it, but like hear my voice. So c squared, so square root of 13. Ugh, what is that? I don't know. Square root of 13, about 3.6, because it's between 9 and 16, so 3.6 is what it says. Okay, so about plus or minus 3.6. So plus 3.6 minus 3.6. 2, 3, right about there. That's not so good, but do the best can. Okay, And so I can write those points as, so my foci are at 4.64 and negative 2.64 as well. Yahoo! Oh, I love conic sections. These were the hyperbolas.